Welcome to the next video on conversion of epsilon NFA to DFA. So here the question given is a transition diagram of epsilon NFA. So from this we'll have to find the DFA, equivalent DFA for this. Okay. So first let's write down the NFA transition table. So here the current states are Q0, Q1, Q2. Q2 is the final state and Q0 is the starting state. So what are the inputs? Inputs are X, Y, Z and epsilon. As it is an epsilon NFA, epsilon will also be an input here. So Q0 on receiving X, it is moving to Q0 itself. Q0 on receiving Y, there is no transition. Q0 on receiving Z, there is no transition. Q0 on receiving epsilon, it is moving to Q1. Q1 on receiving X, there is no transition. Q1 on receiving Y, it is moving to itself. Okay, Q1 on Q1 on input Z, there is no transition. Null. Here it should be epsilon. Okay, so Q1 on epsilon transition, there is Q1 on epsilon transition, it is moving to Q2. And Q2 on X and Y, there is no input. And Q2 on Z, it is moving to itself and there is no epsilon transition for this. Okay. Now the next step is to find the epsilon closure of all the states involved here, that is E closure of we will have to find epsilon closure of Q0, epsilon closure of Q1, epsilon closure of Q2. Okay, so epsilon closure of Q0 is receiving epsilon and it is moving to Q1, and again it is receiving epsilon and it is moving to Q2. So epsilon closure is the state itself and all the states included on the epsilon transition. Okay, so for Q1 it is the state itself, and Q1 to Q2 you have epsilon transition, so it is Q2. And epsilon transition of Q2 is Q2 itself. Even if there is no transition, the state itself will be included. So the next step is constructing the equivalent DFA table. So here we are going to first start with the starting state. Here the starting state is Q0 in NFA. So the new equivalent DFA table will be epsilon closure of the starting state of the NFA, that is here Q0 is the starting state of the NFA table. Q0 is starting state of NFA table. So epsilon closure of Q0 will be the starting state of the DFA. Okay. So what is epsilon closure of Q0? It is Q0, Q1 and Q2. So the first state is Q0, Q1, Q2. So what are all the inputs? X, Y, Z. As it is a DFA, there will not be epsilon transition, so it will not be considered as one of the input. Okay. So now Q0, Q1, Q2 on X, Y and Z should be found. That is transition for Q0, Q1, Q2 on X should be found, which is equivalent to epsilon closure of transition of Q0, Q1, Q2 on X. Okay, So it is going to be epsilon closure of del of q naught comma x union del of q1 comma x union del of q2 comma x. So now epsilon closure of transition of q naught comma x. Q naught comma x is q naught union q1 comma x is q1 comma x is null union q2 comma x q2 comma x is 5 q naught. So epsilon closure of q naught, it is going to be q naught q1 q2 naught q1 q2. So now moving to the next, so it is epsilon closure of the combination of this. Okay, so q q naught q1 q2 on y will be q1 epsilon closure of q1, which is going to be q1 comma q2. Next is epsilon closure. Next is the transition of q0 q1 q2 on z. So it is the combination of these transition and then applying epsilon closure to it. So it is q2 epsilon closure of q2 is q2. Okay. So now we are going to identify the new states formed. So q0 q1 q2 is already there. q1 and q2 are the new states formed. So we are going to identify the transition of q1 q2 first. So q1 q2, so it is going to be the combination of q1 q2, this is q1, this is q2, and then apply epsilon closure to it. So the union of these two is pi. When you apply epsilon closure for pi, it will also be pi only, and then y. Okay, so it is combination, it is union of q1 and q2 on y, so it is q1. So when you apply epsilon closure for that, it is going to be q1 q2. And next one is when you apply epsilon closure for the union of these two, that is q1 q2 on z, it is q2 epsilon closure of q2, which is q2 only. And the next new state is q2. So write the transitions of q2. So here it is epsilon closure of pi will be pi only, epsilon closure of pi is pi only, epsilon closure of q2 is q2. Okay, so now the diagram should be drawn using this. So transition diagram. So we have three states. One is q0, q1, q2. You can replace it with a single name also. And then q1, q2, and then q2. So as you have q2 in all the state is going to be the final state also. You can have more than one final state. So Okay, so here on input X it is moving to itself, on input Y it is moving to Q1, Q2, on input Z it is moving to Q2, and Q1, Q2, on Y it is moving to Q1, Q2, and on Z it is moving to Q2. Q2 it is not having any transition here. On Z it is moving to Q2 itself. So this is the final DFA diagram, equivalent DFA diagram. So I repeat, first identify the transition table and find epsilon closure of all the states, and then you'll have to find the transition of each and every state. For that, the starting state will be the epsilon closure of the starting state of NFA. So identify that and find out the transition either using the formula, or if you can combine and then apply epsilon closure for that, and you can write it directly. Once it is done, you can draw the diagram. You can represent this with a single name also, like say you can replace this with A, B, and C also. Thank you.